Hello and welcome to this recorded learning on embedded system design with the PowerPC 440 processor core. My name is Frank Nelson. I'm a Xilinx technical trainer and course developer. I'll be your instructor for this module. In this module, we will learn about the PowerPC 440's feature set. This module introduces you to the processor architecture and explains its benefits. We're also going to show you how to optimize some of the features of your embedded system with the base system builder. After listening to this recording, you should listen to the other RELs on embedded design. These include the embedded design with the Embedded Developers Kit, that is Xilinx's software package for embedded design, and embedded design with the MicroBlaze soft processor core. These remaining modules complete the course offering. The information in these recorded learnings is essential to the success of our customers as they build their embedded design. However, due to our own time limitations, we cannot teach you everything you need to know about EDK or embedded design, so we encourage you to attend one of our embedded design courses. We'll discuss their content a little bit at the end. So again, welcome to this recorded learning about the PowerPC and embedded design. If you're new to embedded design with one of Xilinx's FPGAs, this module will explain why you may want to use the PowerPC 440 processor that's available to you in the Virtex 5 FX FPGA family. You should also be able to understand the basics of the PowerPC 440 processor after completing this REL. That information is essential if you're going to select an appropriate FPGA device family, or more importantly, build a successful embedded design. The Embedded Developers Kit software called EDK is designed to make building a fast embedded design easy, so we'll cover a little bit of its functionality from the base system builder. But again, to get more information about that, check out that REL I mentioned. After completing this module, you should be able to explain some of the benefits of the PowerPC 440 processor, explain how the utilities included within the Embedded Developers Kit are optimized for the PowerPC 440, specifically in this case as the base system builder, and be able to basically build a system with the base system builder in less than 30 minutes or so. And this will make it easy for you to build your embedded system, so I can't encourage you enough to check out that utility. And we'll have a chance to talk a bit more about that later on. So our first topic will be to introduce you to the PowerPC 440 processor and discuss typical embedded hardware. The PowerPC 440 is available from the Xilinx Virtex 5 FX family and is dedicated in the silicon. This means that it can obtain higher performance and have a top speed of over 450 megahertz. Now, don't forget that the PowerPC 440 we use is the same as the off-the-shelf version. There has been no optimizing or simplifying of its architecture. It is literally the same ASIC, just fused to the FPGA's interconnect. Xilinx's embedded processor solutions include the MicroBlaze soft processor core as well as the PowerPC 440 hard processor core. Now, MicroBlaze is a soft processor core, which means that it is built with standard FPGA logic resources, including LUTs and registers, and it can target any of Xilinx's FPGAs. Now, MicroBlaze is a 32-bit RISC processor that can obtain performance over 300 megahertz, but this again will depend on the device family and speed grade, as well as the embedded system that you choose to build. Both of these processors use the PLB v46 bus standard, and EDK includes IP that is optimized for this bus standard. This means that any IP that is optimized for the PowerPC 440 can be used on a MicroBlaze system and vice versa. Xilinx also provides a PowerPC 405 processor core in the Virtex 4 FX product family. This processor uses a different bus standard than the MicroBlaze or the PowerPC 440 cores. There are several embedded development kits available from a few different manufacturers. Each has its own unique components added to make prototyping fast and easy, and there are a number of different FPGAs to choose from. There are also some that are very inexpensive. To learn more about those available demo kits, go to Xilinx's website at www.support.xilinx.com. Now, as I mentioned, the PowerPC 440 is only included in the Virtex 5 FXT device family. MicroBlaze allows designers to target all of our FPGAs, and these include the low-cost Spartan device families as well as the high-speed Virtex families. So the user, when they're targeting MicroBlaze, is left with a great deal of flexibility to choose a device that meets their cost and performance needs. All of these processor solutions are supported with EDK and include optimized peripherals that save customers from having to build the same IP over and over and build them from scratch for that matter. Note that Xilinx's newest family members, the Spartan 6 and the Vertex 6 device families, already support microblaze and do not have a dedicated PowerPC processor core. A Xilinx embedded system can be nearly any computing system. It is typically single-functioned so that it is small and efficient. This is beneficial to FPGA customers because they don't have to purchase an expensive off-the-shelf component that may already have a large number of peripherals already added. The FPGA solution allows customers to add only the peripherals they need and build any custom peripherals they can't get from an off-the-shelf component. To help with design construction, Xilinx provides a library of verified peripherals that you can add to your system at no extra cost. Typical embedded systems are tuned for low cost, minimal power consumption, relative speed, and minimal FPGA resource utilization. As you may know, many customers like to store their software code inside of the FPGA block RAM. The caveat to this, however, is that there is a limited number of block RAMs inside of the FPGA. But this will depend on the device family and, of course, the density of FPGA you decide to purchase. Typically, most customers choose to use an off-chip memory for their application if they need a large amount of software, such is the case if they need an embedded RTOS. To aid this, EDK includes a number of optimized off-chip memory controllers that support a variety of types of memory components. Spartan 6 even includes a dedicated programmable memory controller that allows you to target most popular memory components in the industry. This is a typical embedded system targeting the PowerPC 440. The PowerPC supports one bus standard, that is the PLB V46. The PLB is designed for 128-bit data and 32 bits for address lines. The PLB bus standard is designed for high speed and high bandwidth peripherals, and it supports dynamic bus sizing and a programmable burst size. The PLB bus standard peripherals are transportable to microblaze embedded systems supported with other Xilinx FPGAs. This allows designers again to migrate peripherals from one embedded system to another. The PowerPC processor supports both a master and two slave PLB buses. The master bus, that is the bus attached to the MPLB port of the PowerPC, allows the PowerPC 440 processor to access any PLB peripheral placed on it, while the slave bus allows other masters on the slave PLB bus to access the MCI memory, that's a memory controller interface port, and the master PLB V46 bus. The PLB bus supports dynamic bus sizing again as well as programmable burst size. The PowerPC 440 also has a memory controller interface or MCI port, and it's designed to connect directly to the PowerPC processor's DDR2 memory controller. The separate memory interface improves system performance and enables access to a large memory. The PowerPC also has 4 direct memory access or DMA ports. These are commonly used to connect to the tri-mode Ethernet MAX included with the Vertex 5 FPGA families. And again, these are dedicated in silicon in most of our FPGA families. This diagram also shows a pretty typical application in which a designer decided to offload some parts of the embedded system to a microblaze processor. In this case, the PowerPC system had its own PLB master bus and also has a shared slave bus that is also connected to a microblaze core. This is done so that the less time-intensive functions can be offloaded to a separate processor. In this example, that is the microblaze processor. The memory controller attached to the master bus can be customized to support ZBT, DDR, as well as other memory component standards. This, like any other peripheral, can be customized to the memory component with the EDK software. Now, often customers will ask, well, how fast can the system run? That will depend on the number and the size of peripherals, as well as the number of buses that you add to your system. Specifically, again, this boils down to how many LUTs and registers will be required for your entire embedded system, and that will determine how fast each bus will run. In this case, the entire system, except for the PowerPC core, is built with those standard FPGA resources, so the speed will depend on the size of the entire FPGA design and the ability of the implementation tools to place and route the design optimally. In the end, the smaller the system, more likely the faster your various buses will operate. But also in the case of the PowerPC core, usually customers are running their buses at a slower clock rate than they're running the actual processor.